All right, and with that, as you probably all just saw the notice that this meeting is being recorded. If there are any questions or concerns about that, please let us know in the chat. And we don't plan to publish this in any way, but we do want it available for our policymakers in the event that some weren't able to join us today and do want to learn about your companies and about the potential for wave and tidal energy in the state. So let me kick it off. I'm Terry Tamminen, the president and CEO of AltaSea at the Port of Los Angeles. And we're hosting this meeting. We're going to ask everyone to please turn off your microphones if you're not speaking, so that we're not getting background noise and any kind of echo. If you during the Q&A session later, we're going to start with presentations and then get to the Q&A. Given how many people are on the webinar, we would ask that you use the raise your hand button if you wanted to ask a question or make comments when we get to that point, and I'll remind you about that. So again, AltaSea at the Port of Los Angeles is a nonprofit that was started to work on the blue economy from the point of view of education, of workforce training, and importantly, of developing the new blue economy businesses. And all of those things are very much tied together as solutions to our climate crisis. And of course, the planet is covered 2/3 by ocean, not by land. And so we know that a lot of the solutions to our climate and sustainability challenges will come from the ocean. But of course, we ourselves have to do that in sustainable ways. We focus, when I say blue economy, on aquaculture, both on land and at sea, on renewable energy, such as wave and tidal and offshore wind and other kinds of renewable energy. That includes research that's being done by universities at AltaSea to extract carbon from seawater, the byproduct of which is hydrogen, and ways that we can use that hydrogen in decarbonizing ports and goods movement. And then the third area we focus on is blue technologies. So things like underwater robotics, sensors, mapping, to better understand our planet and to adapt to the changing climate. And so we're very happy to have with us today quite a few wave and tidal energy companies. I'm hearing a little bit of background. I just want to remind everyone, please put your microphones on mute if you're not speaking. And can everyone hear me? Chris, you want to just confirm?
Yeah, I just muted a few people.
All right, good. So thanks very much. So again, our goal at AltaSea is to advance the blue economy in every way we can. And we are sponsoring Senate Bill 605 in the state of California to try and accelerate the adoption of wave and tidal energy in particular. And the state of California has very ambitious goals for decarbonizing its economy, its energy mix, and its transportation energy mix. And offshore wind, onshore wind and solar, other renewables are well advanced. But we think that wave and tidal energy has great potential to help us complete those goals. And in fact, we probably won't complete them without things like harnessing the power of the ocean in this way, especially because, as you all know, things like solar can be very intermittent and you need batteries or other ways to store it. Wave and tidal energy can be more predictable or more available at the times that those other renewables are not. So the goal of Senate Bill 605 is a study bill. It would ask our California Energy Commission and relevant agencies like the Coastal Commission and the Ocean Protection Council to work on a study that would show where wave and tidal energy could be deployed, what it would mean to our economy, our workforce, our clean energy and decarbonizing goals, and then what incentives might be needed, similar to what the state has done for other renewable energy. So in order for that study to be effective, we think it's important for the industry to be able to speak directly to policymakers who are going to be working on that and then setting those policies. And today is the first opportunity to do that. We've established an informal sustainable blue economy caucus. So some of the folks that are on the call today that represent various members of our state assembly and Senate and the governor's office are working in that caucus to try and help advance these blue economy goals, starting with SB 605 and the wave and tidal energy effort. So this will be the first of more of these kinds of briefings and more formal reporting or input to policymakers. Last couple of housekeeping things before we jump into our presentations, which are really important. We want to hear from each of the companies that are here today. Once again, please keep your microphone off if you're not speaking. When the time comes, if you need to say something, put it in the chat or raise your hand. The meeting is being recorded. And after the meeting today, we'll circulate some notes, but we would also like to circulate contact information. So if you are not comfortable with sharing your email or your contact information, please let Mebus know, who has been in touch with you and has been organizing this, or welcome to send me a note as well. Otherwise, first of the week, next week, we'll be circulating more information to everyone. So with that, I'd like to get started, and we're going to do this in alphabetical order. So we're going to present, I think it's 20 companies. That's a lot to cover. And I know that some people may have to leave before the full 2 hours is up. So we want to be as time efficient as possible. And so we would ask each presenter to keep your comments to 3 minutes. And I'm going to be a brutal timekeeper. I'm going to be watching, and I will cut you off at 3 minutes. So what we're hoping is that you will present your slides or any other information about your company and your technology in the wave and tidal energy sector. And then also anything in particular that you would like to see in the study, or you'd like to get from policymakers, from the government, to try to help incentivize and smooth the pathway to adoption of these technologies in the state of California and hopefully beyond. So with that, we're going to start with AltaSea Systems, and I think Indigo Doria is here with us. Do we have AltaSea Systems with us?
I don't know if I see them.
All right, well, we'll move on to AW Energy and Chris Ridgewell. Chris, are you with us?
Yes. Hi, can you hear me?
Yes, and I think Chris Haddad, you've probably enabled screen sharing so that our presenters can share their slides. And Chris Ridgewell, I'll turn it over to you.
Hi, can you see my slides? Can you see the slide?
Don't see them yet. So you just have to share screen, which I've enabled.
Yeah.
And if there's a trouble
okay.
there, else.
Oh, yes, I see. Can you see it now?
Yes.
Okay, great, good. Okay, thank you. Thank you for this opportunity, and greetings from Finland. So at AW Energy, we develop and sell wave roller technology. And here you can see our first of a kind after 2 years of deployment in Portugal. So at AW Energy, we're based in Finland, as I mentioned. We're certified by DNV to ISO 9001 to design and sell wave energy converters. Our technology has also been scrutinized by the Solar Impulse Foundation and labeled twice. We also hold the EU Seal of Excellence, and the company is majority owned by Finnish family offices. We've also received financing from the European Investment Bank through the Innofin financing facility. And we're also part of Halliburton Labs, who are our most recent shareholder. Here's a photo of wave roller in action. It's deployed in depths of 10 to 15 meters. Here there are thousands of tons, or rather tens of thousands of tons of water forcing the panel back and forwards with the waves. To get to this scale, we've deployed wave roller at different scales over the last 20 years. We've learned a lot in that time. We have 99 patents, over 30 families, a full-scale power takeoff test facility in Finland, and an ocean test site in Portugal, where we recently completed a 2-year deployment. And the technology is also certified by Lloyd's Register to standards common in the oil and gas industries, and this is an essential part of bankability. So we're now rolling out our devices, our product family. As you can see, wave roller X, C, and D at various sizes, power levels. I've just noted a couple of benefits here. The low visual impact from the coastline.
1 minute warning.
Okay, the potential to support coastal resilience and the effects of support artificial reefs, as you can see in the video. So there are a few questions that you asked. So key goals for engagement in California. So we're a small company, but we would love to scale in California. But to do that, as a small company, we need financial certainty, you know, a customer, strong partners, investor. Those are essential to make the move. And the requests for Senate Bill 605 study. I think the first one is please remember the wave energy feasibility study that was commissioned by the city of San Francisco in 2009. I think that was a very thorough and good study and worth taking note of. Maintain a holistic view on you know, the economic value beyond LCOE, and I think, Terry, you mentioned that already. Include nearshore sites, please, for potential pilot projects, 10 to 15 meters water depth, and please consider the other co-location benefits, such as strengthening natural sediment accretion to increase coastline resilience.
Thank you, Chris. That's time, I'm afraid, and hopefully we'll have more time to come back for folks to make more comments or add points, but I do want to be respectful of everyone's time and stick to 3 minutes per. So thanks so much. Let's go back to the top of our alphabetical list. Is Arrecife Systems with us yet?
And Chris, if you can just stop share on that, I think you just go down and stop share on your screen.
And Arrecife is not with us, so let's move to Breakwave Energy. And I think Bill Lyman is presenting. Bill, are you with us?
I surely am, and good morning. And I will start my timer and help you out a little bit there. Okay.
Thank you. Time doesn't start till you get your screen that you're sharing up.
Well, can everyone see my screen?
It looks like it's loading. Yep, there it is. Thank you. Go ahead.
Fantastic. So this is a snapshot of our technology here. We are shore-based, and I got this design from traveling overseas. Formerly, I'm a Navy SEAL, and we have a strong military background with the people we work with. And so that's kind of came to this design. This is a side shot of it here, and what we're relying on, and kind of the genesis of our design is the fact that we try to keep everything that's expensive, that requires massive maintenance, that can see damage from being placed in harm's way or undersea. We try to keep that shore-based, one, to reduce maintenance costs, and then also to capture the most powerful portions of the wave, which are breaking at shore. All right. And so that's where this is. I know there's probably some there's some visual pollution problems we face with this, but we're also looking to not base ourselves near major population centers, tourist spots, and what have you. So stage of development currently at TRL4. We do have a small scale prototype, and we have been testing. We also have clearance to test in some private beaches just south of Ensenada, so that's helped us out quite a bit. Key goals for engagement in California. I mean, we would really like to test on the shore. That would be incredible if we could do that full blown, with the entirety of our system. Right now, we're just doing modified testing. And then quicker access to grants at the lower TRL level. I think that would really, really help us out. That would really push us forward. Desired outcomes for SB 605. Incentives for behind the meter testing. We advocate for the inclusion of incentives and support mechanisms to encourage private entities, right? That's where we want to test. We want to look at everything. We want to look at, all sorts of different setups that we could have. Access to shore-based sites, that would obviously, that would really help us. I think if we could engage with Camp Pendleton, that would be awesome. So access to the base, shore-based sites, wave energy, tidal energy projects, we really want to see the streamlining being permitted. So that, that we think that would help us and marine energy as a whole. Guidelines for environmental and impact reporting and streamlining, emphasize the importance of establishing clear guidelines, procedures. We want to be able to see what's going on. We want to know the unknown with getting everything done and getting our product out there. And that's it. That's what I have.
Perfect timing, right at 3 minutes. Very nicely done. All right, great. And I now understand that Arrecife Systems and Inigo Doria is with us. So can we
Here I am. Okay, it's my turn.
Yes, it is. Please share your
Okay,
slides.
thank you.
And timer 3 minutes will start when you
No problem.
slides up.
Can you see my slides?
I think it's loading, and there it is. Yes, please go ahead.
Okay. So we are Arrecife. I'm Inigo Doria, the CEO, and we have a technology, a unique technology to work with ocean waves, but also with tidal currents. So we know that there is a huge problem with the ocean technologies. They have high cost. The governments are trying to find good solutions to produce energy in remote communities and in a good way. So we have find our way to produce electricity with a floating system with cross-flow turbines that are connected to electric generators. As you can see in these images, the system is more or less like a floating catamaran or trimaran with cross-flow turbines connected to generators. This allow us to produce in a very constant way electricity. So regarding the wave energy technology, we can produce units from 1 kilowatt to 600 kilowatt units. We believe that we can increase the production comparing to other technologies, as we can get the kinetic and the potential energy of the waves, besides other technologies that can work just with the potential energy. And we do this with direct-to-grid system, which is more efficient and with only one mooring line. This also helps us to do a very cost-efficient installation, which is so important because in the ocean, every maintenance and every installation is so expensive. So we reduce a lot this cost by using one mooring line. Regarding the technology with tidal units, thanks to all the tests that we have done in the past with these cross-flow turbines, we are also able to increase the productions as we can put more turbines in the same space with less maintenance costs besides other technologies, because we put all the generators and electric units in the surface, not down the water. So this is a very good idea, because all the existing or most of the existing technologies are using electric components down the water, the generator, the gearboxes. So when there is a big problem or a maintenance problem, you have very high costs. And regarding the installation cost, we reduce this by using standard tugboats. So
20 seconds left.
No problem. The technology, as you can see, we have done tests in the offshore and in the lab, and we are a small team of 4 people that we are looking basically joint ventures in the US, pilots, and maybe we are open also to create a US company. So we have recently been in the South, in the Silicon Valley in Summit with Plug and Play. So we see there are high market potential there, and we want to be connected there. So that's for everything from my side. Thank you very much.
Great, thank you so much. We're going to move on to Sea Power Systems and Services. Christy Terrassa. Is Christy with us?
Yes, I am.
Great.
Let me share. Seeing that okay?
Yes, go ahead.
Okay. Good morning, good afternoon, everyone. Thank you for the opportunity to speak with you today. I'm Christy Terrassa, Senior Associate in Corporate and Business Development at Sea Power. Before I dive into our overview and our hopes for SB 605, I just want to say Sea Power has a presence in both the US and the EU, and believe California is in a unique place to lead domestically in bringing wave energy to the grid because of the economic, social, and political alignment that exists. So our hope is for California to add to the leadership it has already shown for the growth of renewables in the US. Some background on us. We are an ocean energy technology company. We tap the world's biggest and best battery, the ocean, to reduce cost, complexity, and carbon intensity of the global economy. We have over a decade of engineering and testing under our belt. We've sold our initial product to the US Navy and have a handful of deployments planned over the next 18 months. We're targeting a terrestrial grid applications as our ultimate goal, but have also developed a low power system targeting blue economy applications that is commercializing now. This is a little quick overview of our two primary products. Sea-Ray on the left, targeting watt and kilowatt scale offshore applications. Stingray on the right, targeting megawatt scale offshore applications and utility scale electricity generation. Our products are purpose-built for the market segments they cover and are both aimed at diversifying and securing the global energy mix, while also enabling new digital, electric, and autonomous solutions not available today. This is an outline of some of our ideal outcomes of the SB 605 study. I don't have time to run through all of them, but I'll touch on a few, and I'm happy to follow up with anyone interested. As we've seen in the past couple of months, permitting remains a national topic of debate and is a priority for the wave energy space as we reach full commercialization. We think leveraging the infrastructure and supply chain of offshore wind may offer a clear path to both expediting permitting and co-locating wave farms alongside wind farms. Alongside that, it's important to have early stakeholder identification and engagement, both in California and beyond, including utilities, independent project developers, federal entities, and regulatory agencies. Our view is the sooner technology developers can start to understand, port infrastructure and plans, the sooner devices can be deployed both in pilot projects and commercial arrays. And then finally, I just want to call attention to the importance of analyzing economic mechanisms that can help bridge gaps between technology and maturity projects. The Supergen Offshore Renewable Hub out of the UK just released a comprehensive report on how to deliver cost-effective wave and tidal energy with a particular emphasis on contracts of difference, CFD. It's been shown and should continue to be highly effective as a marketable mechanism for both wave and tidal. Overall, I think the biggest need we see is getting past pilot scale for de-risked, market-ready, commercialized technology to bring wave energy to the grid. So this graph is from the DOE Office of Clean Energy demonstrations. It highlights where the need is. We think SB 605 can speak to the same space that OSET is targeting, circled in green here.
Thanks, Christy. Please wrap up. We're past time.
Yep. Thank you so much.
Excellent. Thank you so much. These are really exciting technologies we're seeing and some great suggestions. So can't wait to get all this summarized and share with all the policymakers. Thank you so much. Next up is CalWave, Marcus Lehman. All right, go ahead.
Yeah, hello everyone. Mark Seaman, co-founder CEO of CalWave Power Technologies. We're California-based OEM, and we developed the X-Wave architecture that operates fully submerged, so not causing any visual impact, and at the same time, achieving high performance through capturing all degrees of freedom. Next to that, we have a digital twin that allows full autonomous operation like the modern wind turbine, and also allows full shutdown in extreme conditions. Yeah, these shots were taken from our 10 months continuous pilot in San Diego in collaboration with Scripps, funded by the US Department of Energy as a follow-up to the 2016 Wave Energy Prize. And here we were able to achieve and exceed all test results. We're able to operate continuously for 10 months with zero intervention, 99% availability, and really validate the autonomous controller, the performance targets, the reliability, as well as the survivability. We encountered several larger 10-year scale storms there. We're now in the process of scaling up for PuckWave, a 20 megawatt farm under development, also funded by the Department of Energy, that is fully grid connected, with the goal to operate there for 2 years. We're planning to offer 3 product lines to the market: 100, 800, and 1.6 kilowatt system, and 1.6 megawatts, and all with a capacity factor of 50%. We're a member of the TMA Blue Tech in San Diego, the National Hydro Association, and the IEC Shadow Committee founded in California, so we've been creating local jobs since 2014, and also brought back research contracts to Berkeley, Scripps, Sandia National Labs, and other California-based entities. Main motivation for wave power in California is the climate potential, jobs, industrial growth, energy security, stability, and ultimately cost reduction to the ratepayer. And here specifically, an ideal outcome would be to quantify the cost savings for the ratepayer, similar to the 2019 study that found with 8 gigawatts of offshore wind that would save $2 billion in storage cost for the California ratepayer, conducted by E3 and Castle Wind. Other studies in the UK found similar and really broke it down to these 4 ideal outcomes: the value of renewable dispatch, the amount of energy reduction from fossil peaker plants, savings in annual dispatch cost, as well as cost reduction in battery and interconnection. Next to quantifying these, the potential to co-locate offshore wind, so facilitating using the existing lease areas also for other renewables, and ultimately show the cost reduction potential to co-locate wind and wave, which also academically has been done in several studies.
Coming up on time here, Marcus.
Yeah, and the last 2 points really match fund the US DOE contracts from the Water Power Technology Office that receives about $130 million annually from Congress. So supporting local businesses to match fund these through programs like the EPIC and others. And then, we heard the test sites before, but next to the ones in Ocean Beach, San Francisco, also Cal Poly and Humboldt Bay under Wave Connect have been investigated in the past for utility scale farms.
Thanks, Marcus. Afraid we're at time. We'll have to leave it there. Thank you so much. Next up is Carnegie Clean Energy, Bridget J. Is Carnegie with us?
I'm here. Hello.
Great. Can you share your screen?
Yes, let's see if it's...
Your 3 minutes starts now.
All right. Hi, everyone. My name is Bridget J. I'm the Chief Commercial Officer at Carnegie Clean Energy. We're an Australian-based wave energy technology provider listed on the Australian Stock Exchange with over 12,000 shareholders, mostly in Australia, but some international, with a portfolio of products. I'll focus today mostly on our 2 core products, which are CEDO and More Power, which are wave energy converters. We also have other complementary products such as a wave predictor and a mooring tensioner. We have a long track record. We've been around for a long time, so developed significant capability and have a track record in offshore deployments and testing simulations. Really see ourselves as part of this ecosystem and work collaboratively with other industry partners and academic partners. One I'd highlight today is working with Hewlett-Packard Enterprise on a reinforcement learning controller, which allows us to optimize the performance and survivability of the technology. So our core product has been CETO, which is a wave energy converter that's a large submerged point absorber. And largely this is for large grid and remote market opportunities. There's lots of unique features. The submergence allows us to be increase survivability and lower impact. One of the ones I'll focus on is the intelligent control that we've integrated into the technology, which allows us to adapt to extreme sea states and allows us to optimize performance. At the moment, we are involved in the Europe Wave pre-commercial procurement program, where we've completed phases 1 and 2 and have bid for phase 3, which would see a fully funded scaled prototype deployed at BMEP or EMEC in Europe. And we're also in conversations with strategic partners to deploy projects. And I thought I'd highlight one of our European partners, which is a large utility, has even flagged the west coast of the US as an interesting opportunity to explore together. Our spin-off product is More Power, which is a application where it takes the power takeoffs of CETO and adapts it for offshore demand applications such as aquaculture, where we can really decarbonize the diesel generators that are powering offshore aquaculture vessels, such as feeding barges. We're developing this with the major salmon suppliers in Australia, Huon and Tassal, with the Blue Economy Cooperative Research Center, which I'd love to introduce to AltaSea at some point.
30 seconds.
And just on the opportunity, I think The market leading position is really up for grabs still, and I'd say it's the US or Europe that are going to take it. As an American, I'd love to see it be the US, and I think California has the vision and the leadership to really take some time to look at some innovative models, such as the pre-commercial procurement program. And again, I'd be happy to introduce anyone to Wave Energy Scotland, who's leading that model.
Thank you, Bridget.
Yeah.
That's time. We'll leave it there. And again, we're going to share these decks with everyone's permission in a Dropbox or some other place where folks can access this information later. And we'll make sure that, of course, our policymakers have it. We're going to move next to Core Power and Patrick Muller, and then right after that will be EcoWave. So let's go ahead, Patrick.
Thanks a lot. Great to be here today. I'm Patrick Muller, co-founder and CEO of Core Power Ocean. I'm also co-president of Ocean Energy Europe. So Core Power, we are a Sweden headquartered organization. We have operations in Portugal, Scotland, and Ireland as well today. And in Core Power, we are 75 stubborn minds that have come together and working hard over the last decade to bring solutions to the biggest challenges that have prevented commercial adoption of wave energy. And we brought our point absorber technology to a point today where we have proven how it is protected in storms. And we used advanced control technology that strongly amplifies the operation in regular wave conditions. And this has allowed us to deliver more than 10 megawatt hours per ton of equipment. So typically an increase in structural efficiency of more than 5 times compared to the previous state of the art that we believe is the basis for making wave energy very cost competitive. Our first commercial scale machine, the Core Power C4, looks like this. It's a 9-meter diameter point absorber. It's rated to 300 kilowatts. And you can see it here in Portugal, where it is deployed. We have tested and proven out our technology in the 5-stage product verification process since 2012. And we have tested in Portugal, France, in Scotland at the European Marine Energy Center, and today in Portugal. We're currently working in our stage 5 program, which is aimed at bringing an array demonstration of 4 full-scale machines. And we're doing that with the aim to get type certification from DNV to make wave energy a bankable technology and start after this shipping product into several commercial customer-driven projects. And we spent quite a bit of time in system modeling with different independent experts in energy system and to quantify the value. And we would be very happy to also support the Bill 605 activities in quantifying the system value of wave energy, and through that establish the deployment targets. We would very much like to see streamlining of the permitting processes. We really need to be able to get things in the water quickly to have a meaningful impact on the climate. And of course, in the study, we also suggest that the mechanisms of how to co-finance early farms, whether it's through feed-in tariffs or contracts for difference or similar, should be investigated to get things off the ground and make this happen. And we see huge opportunities for large industrial development in California. In Core Power, we are ready to start building significant engineering and delivery capacity in California. Thanks.
Perfect. You kept it 4 seconds early. We appreciate that kind of efficiency. Fascinating technology all around. So next up is EcoWave and Ina Braverman, and then after that will be Fisherman's Island. So everyone ready? And is Ina with us?
Yes, I'm here.
There she is. Go ahead, share your screen.
Okay, so I'm Ina Braverman, founder and CEO of EcoWave Power. Our company developed a unique innovative technology for generation of clean electricity from ocean and sea waves, where in our technology it's called nearshore or onshore technology, when only the floaters are in the water, the rest of the equipment is on land. Here we can actually see the technology. So basically we have floaters connected to any type of existent infrastructures, breakwaters, piers, jetties. They're going up and down with the movement of the waves, pushing a hydraulic cylinder, which transmits biodegradable fluid into land-located accumulators. The pressure is being built, turning hydromotor, turning generator, and creates clean electricity to the grid. So we have implemented the grid-connected technology in Gibraltar for 6 years. Now we finalized also our second grid connected project in the port of Jaffa in collaboration and co-investment from EDF Renewables IL, Electricité de France, and funding from the Israeli Energy Ministry, which recognized the technology as a pioneering technology. And next thing, we're going to deploy a power station in Los Angeles. This will be at AltaSea premises, actually in the port of LA. This will be our first presence in the United States. And our next planned project is in the city of Portos in Portugal, where we signed a 20 megawatt concession agreement. So our key goals in California and basically with the SB 605 legislation is basically receive a supportive legislation for wave energy implementation, potentially receive a subsidized feed-in tariff, not for all the time for wave energy, but the same like was for solar and wind for a first number of megawatts in order to assist the commercialization of the technologies, have more grants available, similar to Europe. In Europe, there's many blue economy related grants. In the US, a little bit less from what we know right now. So really to see more attention to that. Really have a legislation that states an amount of megawatts offshore, nearshore, onshore from different kind of scenarios of wave energy available. Development of clear licensing procedures, because right now kind of all the ports and locations that are interested in our technology, they're kind of trying to understand which path they should take in order to license the technology, in order to connect it to the grid. So maybe create some sort of like standard and very framed procedure for licensing, and same for grid connection procedures. And in the study that SB 605 offers to do, basically, we would like to receive sketches of the marine structures, which are not always available publicly, have bathymetric maps, because the depth of the water really influences the energy generations, wave data for different developers, onshore, nearshore, and offshore, kilowatt per meter per location in order to identify the best first locations for implementations, extreme weather conditions, tidal information, and of course, nearest grid connection points, because some location might have amazing waves, but no grid connection point available, so a project there is not feasible. Once all this information becomes public, I think all the companies can, use it.
Thanks, Ina. We're at time.
No
Thanks.
problem.
Very good. All right, next up is Fisherman's Island, Yona Becker, and then after that will be Green Finance Corporation. Yona, are you with us? Yep, I see Yona, but we can't hear you. Yona, are you able to unmute? All right, Yona is having some technical difficulties there. So Yona, we'll come back to you. Why don't we go on to Christian Kemper and Green Finance? And we'll come back to Yona when we figure out the technical. Christian, are you with us?
Yes, I'm with you. Thank you very much.
All right, go ahead.
Very great conference you have here. So, yeah, I'm Christian Kemper from Hamburg, Germany. I started my company, Green Finance Corporation, in California in 2006, organizing the first financing for a floating solar entrepreneur from Europe. That was in 2008 then came Obama, then came Lehman. So I went back to Europe developing wind farms onshore. But since 2012, I'm also an investor in a tidal energy company. So I took care of geospatial analysis and development of wind and tidal projects in the European Union. And I'm an advisor for the European Union on Innovation Fund on maritime projects. That is small, medium, and large scale projects. So that means what did we do to find the right locations? That is, we did an analysis funded by the European Commission in Northern Europe, in Denmark and Germany. And also we found locations for charging a hybrid ferry with floating energy in cooperation with a hybrid ferry operator. And next we did, outside of Europe, some assessment of sites, tidal sites at the east coast of the US. And in Southern Asia, which were presented the results at the German-American Forum on Offshore Wind in the US. That was my last time before COVID in the US in December 2019. So I'm very happy to be present here. And let me just give you an overview about the approach. So, of course, you have a technology assessment. There are wonderful technologies, and the major European technologies in development are known to us. So we adapt them, we cooperate with them and adapt them to the specific sites. So after site assessment, what you see on the left upper side is the German BITE, where we wrote an algorithm to find the specific microsites to decide where to deploy the technology.
20 seconds left.
Yeah, thank you. So finally, we do what I do when I have to decide over funding of technologies is just a heat map evaluation. So that's basically, and I hope you understand I don't show too much about one of the client's technologies here, but later always. Thank you very much for the invitation.
Thank you. These are important considerations as we do our study and try to encourage this technology in California. All right, let's go back to Fisherman's Island. And Yona, are you able to unmute and share your screen?
Okay. There you go. Yeah, that's good. You see the screen?
Not yet. I see you, but
Not the screen.
Can you hit the share screen button down there?
Okay. The screen. There's some problem. Okay, try later and try again.
We can move to the next and then I can get it on, I can bring it up on my end.
All right, that's great. So next is Hydro Air Concept Energy, or HACE, and Stefan Guglieri. Let's move on to HACE.
Well, hello everyone. Let me try to share my screen here. Here we go. There we go. I hope you can see it.
We can. Go ahead.
All right. So basically, I just wanted to say two words about key facts. Right now, there's about 25,000 terawatt hours of installed capacity producing electricity yearly worldwide, and the wave power potential near shore is 80,000 terawatt hours. So it's a factor of 3 to the total electricity installation in the world. And actually, more than 60% of mankind actually lives near shore, less than 100 kilometers. And out of the 8,000 gigawatts of installed capacity to produce electricity worldwide, right now we have less than 1 gigawatt for wave energy. So there's a massive untapped potential to produce clean electricity. We at ACE have an extremely simple concept. It's a machine that floats on the water. As the waves flow through the machine, the waves push up and down air pistons. We catch the air and channel it through a compression chamber and flow that through turbines, low pressure turbines, and produce electricity. We are a French-based company, and we have finalized all of our testing and R&D. Recent testing at sea have demonstrated that our case is solid. And we're right now looking for funding to start our first factory to answer the already pretty big customer needs that have been expressed to us. I'm sorry, can you hear me?
Yes,
Hello?
we can. Could we ask everyone else to please mute when you're not speaking? I'm sorry, go ahead.
Okay, sure. So basically, we can produce a very highly competitive electricity from the wave power. As far as ACE is concerned, we have capacity factors between 80 and 85%. We start producing electricity with very small waves, lower than 20 centimeter. The levelized cost of electricity, so the full cost of electricity, if you will, is about half of what produces wind or solar. So it's about 23 euro per megawatt hour. the carbon footprint, and I'll come back over this, is extremely low. It's 20 to 100 times lower than solar or wind power. It's less than 0.5 gram per kilowatt hour produced. And we can actually produce electricity for very small islands starting at 1 megawatt, and then we can pile up and add up several hundreds of megawatts. No obstruction of the horizon line, very light, no concrete, 1 day to install per each megawatt. The one point very important to us with regulators and governments is basically to say it would be very good that all technologies are compared on equal levels and standardized level of CO2 emissions, so that the governments and local governments and state governments can actually make decisions and compare technologies, because wave energy is a very clean energy. It's happening right now, and it's cost effective.
Thanks, Stefan. We're at time. So if there's anything else in your slides, we'll cover them later. Thank you so much. All right, let's try to go back to Yona and Fisherman's Island. I don't know if Yona can control the deck, or Chris, if you want to put it up.
I will share screen. Yona, if you can unmute yourself now.
And Stefan, I think you need to stop share.
Yeah, Stefan, if you can stop share.
I'm sorry, can you stop the share for me? Oh, here we go. Sorry, I lost the button.
There you go. Perfect.
Sorry for that.
And then Yona, if you can unmute yourself, and I have 3 different slides, actually. I'm not sure the order that you want to present them.
Yona, we can't hear you. You need to unmute.
If you go, you'll see it up in the upper right of your box. You just click there. There's 3 dots, and you should be able to unmute yourself.
Okay.
There you go.
There you
Okay.
go. All right. Go ahead, Yona. You have 3 minutes.
Okay. Can you put the other one, the other slide?
Which one is it? There's 3. I just need to know the title.
The fisherman. I'm sorry, it's called.
This one?
The ocean creating a oh right, yeah, this one.
Okay.
So Yona Becker from Fisherman Island, we have new ideas. We have what you see is you see the offshore ocean platform that creating renewable zero emission nature energy. We're using hydro turbines to convert the water energy. We have trap pools where the water can go in, and the wave water it's built offshore, 3 to 6 miles offshore. You don't see it from shore. It's connected to the ocean floor up to 100 meters. It's moored pneumatically from above water level, and the water can go inside a pool. Like let's say high waves can go through valves, one-way valves into a trap pools. So the water goes in. It can be either tide water, seawater, or stream, or current, or wind that create waves. So the water can come from up and down, and come from the sides of the pool. One way, then they trapped and create potential energy, and then the water goes down into hydro turbines that create mechanical energy that we convert to pneumatic energy, and we store it in air tanks. The energy is transferred to the shore, so we don't have any electricity, any generator. It's only pneumatic power. Can you put the other slide there, please?
And we have just 30 seconds left.
Okay. Now the engine, you have the last one, the third one. Right. This is another patent show that the pneumatic engine, it's a pulse electronic controlled pulse generator engine that creates all kind of a lot of energy can be used for even for trucks and SUVs and for electrical generator anywhere on shore, you know. So you have the energy, the pneumatic energy from the sea offshore, 2 to 6 miles. You bring it to air tanks on the shore, and you can use it anywhere, anytime. And this engine is a zero emission, fossil-free engine. It's a new patent, and it can replace the internal combustion engine on vehicles. We have like 270 million vehicles in America.
All right,
Currently,
thank you. Unfortunately, you're at time. We'll share your other slides and more comments later, but just to be fair to everyone, unfortunately, we're at time. Thank you. All right, next up is Motion Energy, Andrea Chow, and then after that will be Novi Ocean to present. So do we have Motion Energy? Andrea? Not hearing from Andrea. I don't know, Chris, if you're able to see the whole list. Let's move on to Novi Ocean, Jan Skolthammer, and then we'll try to come back to Motion Energy if they are there. Jan, are you with us? Yep, there you go. All right, 3 minutes.
Well, good to meet you all and happy to present. Second here. Presentation mode. Yes, Novi Ocean. Our concept is a hybrid solar and hydropower plant at sea, 700 kilowatts initially, later on 2 megawatt per unit. Our mission is saving the climate with profitable wave power. And top right, you can see it presently out to sea outside of Stockholm, powering the island behind with hydropower and solar power. And down right, you can see it in the full scale. You can see it consists of 3 parts: the float, 38 meters long, 8 meters wide, 4 meters high, and the weight is 120 tons. A cylinder in the middle and a hydropower plant on top, lifting 5 times the weight, that's 600 tons in larger waves of 4 meters, and very simple fuel light and simple parts. Impacts and essentials. Weight to power ratio is 1/2 versus offshore wind. Number of parts is 1/2 also versus offshore wind. And area used is 1/2 versus offshore wind. LCOE is 1/3 only versus the start of wind and solar, meaning the potential going below over time. Base load up to 3 times higher with wave power as with offshore wind. And base load combined, this is essence, with wind power up to 5 times higher. And power to weight ratio is 2 to 50 times higher than the competition, importantly. And we said the proof is in the pudding. Why is that? Because today we are probably the only one showing numbers. On the left side, you can see the testing of the unit up to sea now, the 6 meter long unit. The blue is the wave. And then you can see the red line is the test data, yellow is simulation. You can see they match perfectly well. Simulations are proved. Then on the right side, the same simulation is extrapolated to the full scale. Down right, you can see 1 megawatt of power. We're the only company showing this officially. Meaning the real performance matches the simulation to the point there is no doubt about the full size output. And simulations and tests show 3 to 30 times more output versus the competition, importantly. Plan forward. So now we finished with stage 1, 2, and now going into the end of 3, the full-scale pilot design. And then afterwards, the full scale goes in the water outside of Spain in about 2 years. Afterwards comes pre-commercial and commercial areas.
All right, we're at
And we
time.
appreciate. Yes. That was it.
That was it. All right.
Okay, that's good. Happy to connect on LinkedIn. Thank you.
Thank you so much. And again, we're going to follow up with everyone, so you'll have more time to.
Oh, for some reason, we can't hear you, Terry.
Oh, sorry, I'm saying I apologize for having to be such a tough time cop, but we do want to make sure we get through everyone and have time for discussion. And then obviously there will be lots of follow-up. So did Motion Energy join us, Andrea?
I don't see her.
All right, so let's move on to Ocean Motion Technologies, Jack Pan, and then after that will be Ocean Wave Energy.
Great. Can you all hear me and see my screen?
Yes, Jack, go ahead. 3 minutes.
Perfect. Thank you very much. Thanks, AltaSea, for inviting me, and I'm very honored to have the opportunity to engage policymakers and staff from the California legislature. My name is Jack. I'm with Ocean Motion Technologies. We're based in San Diego, California. We focused on powering small-scale off-grid applications at sea, and our core technology is a small-scale independent power unit that can be installed on most commercial oceanographic data buoys. We also have an onboard AI control system that can help produce power optimally in a wide range of ocean environments. So in the top right photo, you can see our pilot customers working with their data buoy, and our device will be installed on the top side of that platform. And the small-scale wave energy can be applied to several existing market demands, and these include power for ocean observation, maritime monitoring, offshore aquaculture monitoring, and the surveillance for coastal security. And generally speaking, small-scale ocean energy can power devices that collect big data of our coastal ocean and provide forecasting to support decision-making and public policy. The goal here is to help the blue economy to transition to a big data paradigm through this ocean of things, but power is still a major challenge in the ocean, and your support can help us realize this paradigm and can facilitate multiple use cases that are highly relevant to California. So for instance, Big Blue data can support fishery and EEZ management along the California coastline. Wave-powered environmental monitoring can support baseline measurements for offshore wind, wave, and tidal facilities, and also offshore aquaculture farms. And support MPA conservation efforts. It can also support continuous coastal water quality measurements and surveillance for port security, both of which are very important for local municipalities. And finally, there is a potential to establish an array of continuous monitoring stations along the Californian coast. Lastly, I was asked to prepare some key messages. First is to raise awareness regarding small-scale ocean energy. This type of ocean energy allows for rapid development and implementation, and the scale is usually not an issue in our case. There's also a very strong market demand already, and there are also existing federal and international initiatives that advocate for off-grid small-scale ocean energy development in addition to grid-scale applications. Secondly, the whole point of environmental monitoring for offshore wind, wave, and tidal is to allow for permitting of these facilities. So permitting for environmental monitoring itself should not be a major challenge. And lastly, I think the CEC and other California agencies can improve the granting and the compliance process. I think there are many very successful programs, both at the federal and already in our state level, that can serve as examples. And that's all I have. Thank you very much for your time. You're muted, Terry.
Thank you, Jack. We owe you 20 seconds. You brought that in early. Terrific. All right, let's move on to Ocean Wave Energy, Forward Ames, and then after that will be Oscilla Power.
Yes, hello. It's going here. Screen.
All right, we can see that. Go ahead.
Do you see full screen?
Yes, thanks.
Okay, thank you. Yeah, this is Ford Ames Ocean Wave Energy Company, started in 1978, and working on a modular self-supported system that directly converts wave energy to electricity, and it uses a counter-rotating generator that's biased to getting the most power from the upstroke buoyancy, the displacement of water, with fairly hydrodynamically optimized buoys. And then the downstroke gravity force spins in opposite
component of the generator, and the relative motion between them increases the power output per unit. And there are 3 of these per module that get series connected together and get connected with other modules through basically just quick connect couplings. And it can be various scales to match the dominant wave height, the annual wave height in a particular region, thus the 3 people on the right side, just showing conformal rescaling of most of the components. It can be just like clicking your magnifier, can be scaled up or down for the annual wave conditions. So it uses a ballast bladder, and that optimizes the depth of the unit. And I'm trying to find my advancer. See.
Maybe just click on the next slide on your left-hand side there.
Yeah.
Here we go. Okay.
There you go.
Basically, the idea is to have it just below what I call the hydroface, the hydrogen-oxygen interface between air and water. And so the idea with the neutral buoyancy, it's probably least expensive to support equipment just below hydroface, and it gets increasingly more expensive with depth. It's also expensive to support equipment above hydroface. So in this case, we're also looking at mooring systems that is shown as a taut mooring, but it's actually a slack mooring system that allows for widely distributed connected units called OWEBs, ocean wave energy webs, to reduce the number of moorings per unit, which saves a lot on the cost.
20 seconds.
Excuse me?
20 seconds.
20 seconds, okay. And so there are people developing seafloor architectures for high voltage direct current, and we think hydrogen production from ocean water is likely. So I've been doing a global deployment plan, and we're an offshore deeper ocean technology. We really believe in coastal regions should be left mostly unhindered. But what we are looking at is HVDC transmission and also hydrogen transmission to shore, and also for ocean functions.
All right, thanks. We're at time. So again, if there's more comments, we'll have to follow up later. Thank you so much for that. Next up is Oscilla Power, Bulky Nair. Bulky, are you there?
Yes, I am.
Terrific. Go ahead. And then after that will be Paddle Power. All right, go ahead.
Let me know when you can see the screen.
Yeah, we can see it. Go ahead.
Okay. So at AltaSea Power, our vision is to enable the shift to 100% renewables with wave energy. One thing that is less well known about California is that wind and solar, when you look at it from a seasonal perspective, are not perfectly complementary. They tend to peak at roughly the same time of year, and wave tends to peak in winter. So this is a really good opportunity for wave to be deployed at a massive scale to hit 100% renewables. That's not just us speaking. Independent studies such as this one that came out of Sandia validates it. Even at 3x the cost of solar or wind, there's a role that wave energy can play, and a pretty significant role. But once they can drive that price down with deployment and get it down to something that's cost compatible, it turns out to be one of the best resources out there very quickly. So that's what we can do with our AltaSea Power Triton system. We have an incredibly efficient system that can get enough electricity from a 1 megawatt rated system to get to power up to 300 California homes. This is supported by 25+ patents. It can survive in a tsunami or in a 75-foot storm wave. It's cost competitive at scale. Once you get up to 50+ megawatts of deployment, we can get to 8 to 10 cents per kilowatt hour. Still a bit more expensive than solar, but not too bad based on that cost curve that I showed earlier. This is significantly independently validated by agencies such as DOE. We are a Wave Energy Prize finalist. We have $20+ million in grants from DOE and other agencies. Science risk has been eliminated. We are at full-scale deployments for our 100 kilowatt rated system. Our megawatt class system will be deployed in India in the next 2 years. We're doing a detailed design for PackWave currently. How can California help wave developers? We think that we can do more in terms of smoothing the permitting process. So, for example, take the PackWave permitting and find ways to smooth the process to apply those to California waters. Encourage developers, including the ones out of California. The best technologies can come from anywhere, and those can be done through grants and subsidies. Some of the financial risks that early stage project developers can incur, if that can be underwritten by the state, that would be one way to encourage early projects to be financed. And lastly, this is not a California thing, but just to select the right technologies, there's a lot of work that has gone in by DOE, Water Power Technologies Office, and other agencies to vet technologies, and you can rely on their expertise. A lot of people make a lot of claims in the space, and it's important to know who's real and who's not. Thank you.
Terrific. Thanks so much. We're going to go back to Motion Energy now. I think Andrea did join us. So if Andrea, if you could share screen, that would be great. And interesting, just a comment here on what we're hearing consistently here about the need for the state to be more involved in permitting. I think it's not just kind of perhaps streamlining permitting, but making the process transparent and time efficient. So that's definitely one theme we're hearing over and over again. Terrific. All right, Andrea, go ahead.
Can everyone hear okay?
Yes, thank you. 3 minutes. Go ahead.
Great. So great to be here. Andrea, I'm the Business Development Manager at Motion. We're a wave energy developer based in Scotland. Just flip this. There we go. That should be full screen now. So our core technology is a asymmetric floating hinge raft. So 2 holes connected by a hinge. The waves cause a reciprocating pitching about the hinge. There's a generator in the hinge. It's a flat mooring system, so we're depth agnostic, and it's passively survivable. So it just dives under the steeper waves to shed the extreme loads. So we were founded in 2015. We class ourselves as a second generation wave energy company in the sense that we're building on past commercial and technical experience. So, and that translates into our roadmap, which is on the next slide. We received about £10 million, just over, in funding, most of that through public support. And in 2021, we launched our first full-scale prototype. So it's a 10 kilowatt machine 2X that you see on this image, and we're now on our second deployment, which I'll also touch on. Passionate about wave energy, about commercializing it, and about using it to enable sustainability in different ways. So we've identified several markets, and we're taking a slightly different approach to companies of the past. So we've really taken the concept of learning by doing to heart. And so we're starting at the small scale, where we've identified markets to do with providing local renewable power off grid. So the value propositions there are about electrifying subsea assets and decarbonizing them. So enabling new technologies like residential robots and all electric systems, and also decarbonizing, as I say. So that's where we're doing our second deployment, which is the microgrid system that you see there. So connecting our WEC to a subsea battery, subsea control module, and residential AUV. And that's a joint industry demonstrator project with technology integrator and operators as well. That's our first market, and then we're looking to step up to the mid-scale and then the grid scale. So the mid-scale market being islands and remote communities, so at the hundreds of kilowatts, we're actively deploying that machine. And then ultimately the grid scale, which we're leaving to 2030 and beyond, although there is some concepting work ongoing. So as you can see through the TRLs levels, we start at small, we're close to commercializing that one, and then we're hoping to reinvest our learning and revenues into the larger systems. And this is my final slide. So although one of our co-founders is American, we are not super familiar with the California context, to be honest. But it was interesting to read the Senate bill, and if our understanding is correct, this is essentially a commitment to a study that, if favorable, would further California's agenda towards marine renewables. So as Motion, we're very supportive of this, and I've just
Thanks, Andrea. We'll summarize this for the team, and again, we'll share this with everyone in Sacramento, but I apologize, you're over time at this point.
Perfect. No
So
problem.
thanks so much. Very good. And next up is Paddle Power, and then after that will be Swell Seawave Energy Limited, and we're getting close to the last few, so we'll get into our Q&A session and discussion shortly. So Nick, go ahead.
Have you got everything?
Yes, we can see it in here. Thank you.
Excellent. Thanks, everybody. And yeah, plenty of technology here. I think Christy from Sea Power basically stole everything that I was more or less going to say. So which is absolutely great, because that means that a lot of us are singing off the same hymn sheet. We have really new kids on the block, and very much at the kind of early stage, although today we've just filed our first patent, having finished with Southampton University and their flume tank, with technology, which is our second prototype that is in water testing. So we do things more or less the same as what I think Elon Musk does, and that we live right on the beach in a very strong tidal area. So we put everything in the water first, and then we take it to Southampton University to get it validated. So we're quite happy. So we'll certainly do more of that later on. So not really much about my kind of, or our kind of technology, but very much what the opportunity is for California, which I think is absolutely huge. And you've taken a kind of leadership position in the renewables, which is great. All I can do is reiterate what everybody else has said. The consenting, great. Please create an incubator that effectively streamlines all of the agencies into a testing area that has the necessary grid infrastructure and for enabling very short or very close export cabling for all the technologies. And having that kind of capability that exists where it's all mapped out for us. It's very straightforward, and we can all rock up and do the same thing with all of our technology. Innovation, please ensure that academia comes on board and provides the necessary help as well, which is very good. And again, locations. Unfortunately for California, you've only really got Golden Gate Bridge as the kind of tidal area that's going to give you any decent tidal streams and energy from that. Wave, yes, we're going to get there. We're going to concentrate on tidal first. But yeah, we'd love to be a part of it and help you wherever we can. But everyone said everything, and yeah, look forward to going forward with you.
Terrific. Thanks so much, and thanks for being time efficient. Fantastic. Let's go next to Swell Seawave Energy Limited, Alexander, and then we'll go to Wave Swell Energy.
Hi, everybody. Can you hear me okay?
We can, and we can see it. Go ahead. You have 3 minutes.
Thank you. So we are Seawave Energy Limited. We are a company that focuses on the design and development of our novel wave energy converter called the Waveline Magnet. So this company started over 15 years ago. Here you can see in 2006, it was one of the first concept designs we started. Later on in 2008, we scaled up the technology and deployed it here off the coast of Cyprus, just right behind my shoulder there. In 2012, we worked closely together with the University of Exeter on another system which we developed. Later on, that same system was taken into Coast Wave Tank in Plymouth and tested there with their service providers. We also carried out some complementary tests that year. In 2014, we built our own wave tank. So we've had a lot of freedom in regards to the testing we've been able to carry out in various experiments, something very few companies in this industry have. In 2016, we scaled up the system and deployed it off the coast of Cyprus for an extended period of time. The power produced by this system was used to charge batteries. In 2018, we made some refinements on the technology. The model you see in here in this picture, which is actually in our wave tank, was taken on into our first European project where we worked with the University of Cork in their Lira test facility and various European service providers to carry out testing on the system and performance analysis. Later on, that system was scaled up 2 times and taken into our second European program, where it was tested in ECN France for over 2 weeks with 200 individual tests and wave profiles of the system. And with these tests, we set the basis for our scale projections. So something to know about our technology is that it's a raw power producer. So what it does is essentially it takes in seawater as its operating fluid. We don't have things like oils and harsh working fluids on board. And using a power takeoff system, we pressurize the seawater, which has a very stable output, which can be used for various conversion processes, whether that be for electricity, onboard desalination, and also, of course, onboard the hydrogen production with the potential of storage. So you can see the left, the system can be deployed into any sea climate, whether that's something very moderate, like we have here in the Mediterranean, all the way through to the most energetic climates in the ocean, of power ranges starting at around 15 kilowatts and surpassing 100 megawatts of power production for single systems. Of course, the technology provides a lot of real estate for various other technologies, whether that be floating solar. Aquaculture is a big deal for this technology. It can be a self-sustained fish farm. The nets can be placed under the system and used for aquaculture. This is just a case study to show the system's levelized cost of energy. Mechanical power at 2.5 cents per kilowatt hour for a location that has an annual wave average of 3 meters and an annual production of this specific system of 140 gigawatt hours.
We're at time, Alex, so please wrap up.
Yeah, so that's it. As of now, we're moving into our final pre-commercial pilot test. In regards to the bill and the objectives, I mean, everybody's really said everything I wanted to say. Something I just would like to stress is regarding open access to data, which would be a big help to companies. Thank you.
Terrific. Thank you so much. All right, next is Wave Swell Energy, Paul Geeson, and then our last presenter, last but not least, will be Wen Verter. So go ahead, Paul.
Yeah, good morning all. Paul Geeson, I'm the CEO of Wave Swell Energy. We absolutely commend the passing of Senate Bill 605. Wave Swell is a company formed in 2016 here in Australia, and we're a small team that believe very passionately that wave energy in the mix represents a really key additional lever in the renewables mix to actually manage and reduce conflict inherent in the approach with achieving not only emissions-free electricity, but also very low cost and reliable electricity. To provide some background on WaveSwell, we deployed a demonstration pilot of our technology in 2021 in the Southern Oceans in Bass Strait at King Island. Within the trial of our technology, we achieved a 50% conversion efficiency wave to wire, which we believe is an industry-leading conversion efficiency. It was important for us that anything that we did in the demonstration was proven and validated. We worked closely with the US Department of Energy through PNNL in terms of an independent assessment and validation, also with the Australian Maritime College from the University of Tasmania. Some important features of our technology: no moving parts in the water, which has been critical to the reliability of our technology, safe access, lower operating costs, and indeed a benign impact on the environment, which again, we independently validated. Whilst our technology was proven in a near-shore application and platform, the technology can be quite agnostic in that it can also be applied in floating vessels. It can also be applied in fixed and floating offshore structures. Importantly, also, our technology can be incorporated in breakwater. So as you saw in the earlier picture, the technology lined up side by side or indeed incorporated in existing or new breakwater infrastructure can actually bring a real trifecta in terms of the benefits associated: clean emissions-free electricity, a source of coastal protection, and certainly indeed the opportunity for a revenue stream that then is associated with what would otherwise be the sunk cost of the coastal protection infrastructure. Importantly, we've actually just commenced a piece of work with the National Renewable Energy Laboratory of the US Department of Energy in some early stage assessment of the feasibility of the incorporation of wave energy converters in coastal protection infrastructure. In terms of the Senate bill, I think much has been said. We certainly look forward to seeing the quantification of the economic, the social, the environmental benefits associated with incorporating wave energy in a mix. Policy and market settings being critical to establishing confidence, financial schemes to push and to pull the technology and that to scale,
It's been said, but identifying suitable locations, a streamlined permitting process, and of course, let's accelerate and see if we can't demonstrate some of these technologies in the waters off California. Thank you.
Terrific. Thank you for being time efficient. Very impressive. And finally, last but not least, Vassos, if you are on from Wenverter, we want to hear from you. I see your screen there.
Can you hear me, Terry?
Yes. But
okay, wonderful. Wonderful. Hi, everyone from Boston. Thank you, Terry, for the chance.
We're not seeing your slides, though. We're seeing
okay.
a Zoom logo. There you go. That's it.
Okay, wonderful.
All right, go.
Wenverter has started in 2019 in Scotland. However, we've been into this development of wave energy for the last 12 years. We have started previously to Wenverter company in Massachusetts, which is called AltaSea, and we had few projects with NL and MIT and the Department of Energy. Now these products that you see on the screen are refined products from all of these efforts. We have a portfolio for accommodating the near shore. We accommodate also offshore with floating devices. The first device is called the surge turbine, and it's a scalable offshore. It's a scalable near shore oscillating wave surge converter with a PTOs that they convert directly wave energy to electricity. The other device is called solar wave. It defines its own category. There's solar panels on pontoon boats, where in the pontoon boats we have the electrical producing PTOs, and the power produced from both kind of devices can go up to megawatt scales. For the first one, wave surge turbine is about from 100 kilowatts to 2 megawatts in an array. The solar wave can produce, I put there up to 5 megawatts as it shows with 6 pontoon boats, but it can go more if we scale them up with additional units. We are into commercialization stage of the surge turbine and to the pre-commercialization stage of the solar wave. On the solar and wave, these devices have been developed in collaboration with the Massachusetts Institute of Technology and the University of Edinburgh in Scotland. We have numbers. Whoever is interested to know more about this, they can reach us by email or through our website. What must be most intriguing to our legislators in the potential impact of these projects that could have in the communities are the importance of engaging them effectively, and the framework for selecting such projects needs to be well thought to ensure economic development benefits and environmental plans.
Thanks, Vassos. We're at time.
Okay.
So
okay.
We'll share your slides, and again, we'll follow up with everyone. All right.
Thank you,
so I want to thank everyone who presented. Are there any other companies on that didn't get on our list for any reason? If that's, I know there are several other companies in the wave sector that are interested, and we will include some of their information, those who were not able to participate today. But I want to go now to Dan Kamen, if Dan is still on from UC Berkeley. I know he had some overall thoughts and is one of the gurus of our clean energy policy in California for many decades. Dan, are you there?
I am definitely here if you can hear me.
We can hear you indeed. So take the floor and then we'll get on to other Q&A, but I wanted to get your reactions and comments first. Go ahead.
Well, it's very kind. I'll share a slide if you don't mind. And first of all, I just wanted to congratulate everyone. It's delightful to see the range of technologies. And in theory, you can see my slide now. My laboratory here at Berkeley does a number of marine energy integration modeling for the state with a modeling package called Switch. And I just wanted to highlight that in addition to the technical specs that you're sharing and those that you can share and those that you can't share, we've been using this model supported by the state of California, both for looking at clean energy integration in the WEC region, but also you can see in the map some other parts of the world, but to look at what it takes to integrate in clean energy targets. And right now, California has now launched a truly aggressive 85 gigawatt total. I'm going to leave all model details aside because I assume I have 1 minute, not the 3 that you guys had. But anyone who wants to share details of their technology, in the slides, you'll see my email address. It's just Cameron@Berkeley. But the thing I want to highlight as we look at how California is going to meet its energy mix is really a key bit of the story, and that is beyond the technical performance. There's no question that now California puts a great deal of weight on the distributed generation, the storage equivalent reliability, and specifically the justice component. And I say that because the federal Justice 40 program that some of you have contributed heavily to, that requires 40% of infrastructure spending on marginalized communities. In California, that's where that came from. And California has a 35% minimum. And in rating programs, in fast tracking projects, there's no question from the Energy Commission to the Public Utilities Commission to the grid operator, that criteria is key. So those of you that track jobs per kilowatt or jobs per megawatt, outreach to communities, those things count in a quantitative, not just a qualitative way in fast tracking projects for state deployment. And if there's no better final comment, it's this slide here. President Biden's first full day in office, he passed an executive order, very challenging route, but that required a social cost of carbon. And that comes directly out of the California process. So those of you thinking about getting hardware in the water or permitting, just make sure that the justice components of what you put together are really seen as not an add-on, but a real co-equal. And part of my task in doing the modeling in this efforts for California is explicitly to do that. So here at the bottom, you see the Twitter, the email, and the URL. And one of the modelers, Alexander Grayson, who can just wave her hand, is online here. So we're happy to follow up. But I just wanted to highlight that this is really seen as not secondary to the kilowatts that you can produce, but it's really core to all of the analysis the state is doing. And 605 will have to reflect a clear justice mandate to move things ahead. So thanks a lot. Happy to talk offline. And Terry, thanks for letting me hop in.
Dan, thank you. As one of the deans of our clean energy strategy and policy in California, I think it's really valuable that you spent your time with us today and gave us these very important points. And at the risk of inundating your inbox, I know you mean it sincerely when you put up your email and you encourage people to reach out to you directly. So folks on the line, please feel free, as you get to know Dan and his amazing work, I would suggest, look online and see all of that work and where the intersections are. And Dan, I hope we can count on you as we move forward with SB 605, any final amendments. But then that the reason for this working group, which will continue, is assuming the bill does pass, and it had, I think everyone should know, we had full bipartisan support in committees in both houses, the Assembly and the Senate, unanimous consent from those committees, which is rare these days on any environmental bill. And I think that's in part because it does try to cover not only environmental, but also economic and job opportunities, but in a just transition manner. But again, Dan, thanks so much and really appreciate your continued input on this, because if we don't inform what the study should look at and then what the final recommendations are, we obviously will come out with the wrong product at the end that doesn't accomplish these goals. So thank you so much. And on that note, before just opening it up to any final comments or questions, and we do have more time left, we did schedule this until the top of the hour, but we don't have to take all that time if we don't need it. I do think that Chuck Gentry from the California Energy Commission may be on the line, one of the Energy Commission team that may be working on this study. Chuck, are you on still?
Yes, I'm here.
Hey, Chuck, I don't know, given that you're at the Energy Commission, if you have any comments or thoughts at this point that you'd like to share, or questions you'd like to ask of any of the participants?
Yeah, sure. I just like to say that we don't currently have any funding available for wave energy projects, but we're currently evaluating the wave energy and other marine energy as potential area for our next EPIC investment plan. Currently, in the current EPIC investment plan, we've focused a lot on offshore wind, and we actually have 7 new agreements that we're recommending for funding, and those are hopefully getting off the ground soon. But yeah, wave energy is something we're considering for the next plan.
And Chuck, if you could just especially for our colleagues who are perhaps from Europe and other places, if you could just explain EPIC. I can never remember what the acronym stands for.
Yeah, EPIC is our research and development program funding source. We have $126 million per year, I believe, that we have to fund various research and development projects. There's a wide array of different topics, and we have an investment plan that we follow, and then we put out solicitations that target certain technologies.
Great. And I should just highlight that EPIC is the program that tries to do things that will benefit California ratepayers, so people who are paying for electricity, whether that's through a municipal utility or an investor-owned utility. And so these are things that obviously, if we can put more clean energy on the grid and save cost and have greater reliability, those are obviously things that will benefit all ratepayers. So thank you very much for that. I wanted to also mention, before we go to any other comments or questions, that we know the legislature and the governor are thinking about bond measures that might be put on either the primary ballot next year or the November ballot next year, and that some of those might be for environmental infrastructure. And so again, thinking about opportunities for how we might inform that. For example, I know that one of the drafts that's circulating right now focuses on enhancing port infrastructure to the degree that it can support offshore wind development. But it would be, I think, a shame to miss out on using that very same infrastructure to support wave and tidal energy, some of which might take even less land, but would obviously provide jobs. The same people who are going out and installing offshore wind could be installing some of the technologies we've seen here today, or supporting the maintenance jobs, et cetera. And whereas, offshore wind is going to take huge acreage for laydown areas and assembly and towing the platforms out to sea and all those types of things, some of the technology we've seen today will take up much less space and be closer to the shore and so on. So I do think there's great synergies there as we look at ways that the state is going to be spending other money for all of us to try to be influential and educate policymakers on these issues. So with that, just because there are a lot of people on, if you have a comment or question, please use the raise hand function, and we can stay on as long as folks have productive conversation they want to engage in here. And if not, we can give everybody back some time in their day. And Chris, I don't know if you're able to see all the
I'm just looking to see. And I don't see a raised hand. And if there is one and I don't see it, just if you want to say, I have my hand raised.
right, or if you don't know how to do the raised hand thing. It took me a long while on Zoom to learn how to do that.
Oh, Marisa Hagerman has her hand raised.
Go ahead, Marisa.
Well, nice to meet you. Marissa Hagerman with Senator Gonzalez. Just wanted to know, when we're thinking about things like solar and wind, and then obviously wave and tidal, I think we're trying to the best we can conserve like our natural resources and pristine coastline. Compared to solar, how much energy can wave and tidal produce in terms of like the water mass it takes up? I guess I'm just worried about if we were to scale this, how much of our ocean space would be taken up.
Marissa, that's a great question. And of course, it really depends on the technology. But there are several technologies you would have seen today that, for example, mount their systems on existing breakwaters and jetties. So infrastructure that's already in the ocean, that's already been permitted, and that is designed to actually absorb wave energy. There's others that could be co-located with offshore wind. So that way, certainly they might take up a little bit more surface space if they're floating or if they're installed on wind platforms, but could piggyback on existing cabling of getting the electricity into shore. So I think that's one of the reasons that SB 605 is focused on having the Energy Commission take the lead in the study, but in consultation with the Coastal Commission and the Ocean Protection Council and any other relevant agencies to make sure that those considerations are considered. So Chris, I don't know if you want to.
Yeah, I'm tracking the hands raised. We have next up is Nair, then Jan, then Daniel, then Patrick.
Yeah, this is Balki from Oslo Power. I had a question for Chuck Gentry from CEC, and I was wondering if there is awareness of that study that I referred to in my presentation, which came out of Sandia, in terms of how wave can fit into the overall energy picture in California and ultimately help to deliver the lowest cost pathways to 100% renewables. And I was wondering if there's sort of a awareness of that study and whether making that more popularized might help to move things along a little faster at your end.
I'm not sure about that particular study, but we're evaluating, several different options and different studies to look at the wave energy as a whole. And yeah.
Yeah, if you're interested, I'd be happy to send you a link to that paper or something to take. It's quite interesting.
Yeah.
If you could, Buck, if you could put that maybe even in the chat so everyone could see it, or just send it back to all of us. That way we'll be sure to share it with everyone.
Okay, will do.
All right, back to you, Chris.
And Jan?
Yes, hi there. Just a comment for Marissa's question. It is generally assumed that wave power can give in the range of twice the output per sea area in comparison to wind power. Of course, depending on the system and efficiency and all, but at least the same, generally more output for the same sea area. Of course, then combining wind power and wave power is the best option when that is suitable, depending on depths and et cetera, But generally, more efficient than wind power is what Ocean Energy Europe and other ones have come to conclusion of.
Daniel?
Hi, yeah, I just want to say thank you very much, Chris and Terry, for putting this on. It's really fantastic. And just an incredible number and diversity of great ideas and projects out there. I do want to kind of echo, I think, what Marisa was getting at, which is with regard to the impacts on environment, specifically biodiversity and habitat. In California, we have executive orders on biodiversity and on habitat conservation that I think are going to be central as we figure out which elements to invest in and where to put the focus on de-risking. And so I would suggest that that folks working on pitch decks that might be longer than 3 minutes include some statement with regard to the habitat and biodiversity impacts. Certainly before you start talking about streamlining permitting, need to make a case that your technology is starting out of the gate with lower impacts. And I think that's going to be important in a market like California. So thank you again. This has been super enlightening. Really appreciate it.
Thanks, Danielle. That's a good point.
Patrick and then Marcus.
Thanks. Yeah, a comment on the spatial efficiency. I think you can typically achieve something like 15 megawatt per square kilometer. So very effective use of ocean space compared to offshore wind. That might be between 3 and 5 on typical offshore wind farms today. So I think that can be very effective. On environmental monitoring, there's great efforts made already. And we and many other developers spend big efforts on monitoring, and there's lots of data to be shared. So I think we are in a good position. PNNL is running this great website, which is summarizing all the different environmental impacts. We can post that one as well. The question I wanted to ask was related to permitting and impact is one very big point to make this happen. The other one, of course, is how do you get financial viability on early stage projects? So for any new technology that you do in relatively small scales in the beginning, you're starting a bit high and then quickly costs come down with technology maturity and volumes. Is it foreseen in this study that there will also be a look at what kind of funding mechanisms that can make the first 10 megawatts, then the 50 megawatts, and then maybe moving to 100 megawatt projects happen? Or is it not including the way to fund them?
So I think right now the bill is very general in terms of what it's directing the Energy Commission to study, and the Energy Commission has done this sort of thing before. We actually modeled this legislation on, I think it was Assembly Bill 525 from 2021, which helped to identify the pathway to offshore wind, which has obviously had a good impact. And I think there have been similar study bills in the past. So right now, I mean, that's again the reason for this working group, so that industry can speak directly to our policymakers. This was a good start today. We'll share all the slides and all the comments, and then hopefully when the bill passes, have some more formal way to inform the process and the questions to answer. Because of course, the worst thing would be to get to the end of the study and say, we should have at least thought of this. So we want to make sure at least all the questions are asked and answered. Chris, back to you.
Marcus, then Jack, then Dan. I'm sorry. Yeah, Marcus. Yeah.
Yeah, first of all, thanks of putting all this together and bringing the industry together. And yeah, glad to continue supporting the efforts in Sacramento area here locally out of California. For Daniel, I just wanted to point out our deployment in San Diego. There is a third-party environmental study by PNNL that has been conducted and is publicly available on the environmental impact, but yeah, we'll make sure to highlight that. And regarding the EPIC, yeah, just wanted to point out we've been advocating for the industry for a while here now, as that started in 2014. So the challenge with EPIC historically was that there's a research roadmap that gets only assessed every 4 years. And I think last time the industry was evaluated as too low in TRL to be considered, or it was a little late in the process as well. So hope that in the next time that roadmap is being conducted, because that's really the only key to then unlock EPIC funding, is my understanding. So glad to support the, last time we supported the agency that conducted that technology roadmap.
Jack?
Thanks. So my comment is regarding Dan's comment earlier, and also tagging on to what he mentioned about permitting and streamlining the process. You know, we make a small scale ocean wave energy device, and that's specifically targeting the environmental monitoring application. And my previous comment on streamlining permitting issues is regarding the environmental monitoring piece, right? I understand that there should be very rigorous environmental monitoring process, and a lot of our colleagues, like Marcus alluded to earlier, have done these procedures and went through this process. But the problem is there's also a rigorous permitting process for the environmental monitoring to get the permits for the offshore facilities, and that's very counterintuitive. And I think there should be a little bit more of ease of access in terms of getting the environmental permitting done for the monitoring piece, so that we can get the permits in place for these offshore energy facilities that a lot of the grid scale companies that are targeting.
Dan?
Yeah, it was just a quick follow-up, and I did put it in the chat, and that is for those who want to kind of look at the good and the bad of the California process, to think how it'll apply here to tidal and marine. When California passed AB 1526 back in 2014, it was seen as kind of a small bill that would enable storage to come online. There was some fight back and forth. The state did put money in to help pilot companies get in the water to deal with some of the permitting things that Jack just mentioned, as well as making sure the projects did go to underserved communities. And the second part of it is that if you come forward to today, nothing is perfect here, but California now has individual storage facilities up and running that are larger than the total mandated amount for 2020. So we have the Moss Landing storage plant, which when it's working is 1.6 gigawatts, and the whole mandate for 2020 was actually initially 1.2. So I don't think offshore energy will go exactly the way storage did, but with its bumps and starts, California does put not only the financial weight to help companies get over the hump, but also a requirement on utilities to adopt. And they don't always do it willingly, but there is a good tug back and forth. So again, I would urge you to talk to CalWave on the call here, because they've worked through the process as an example of getting hardware in the water in California.
Thanks, Dan. Those are very good points. And just to go back to the whole permitting issue, and Daniel Glusenkamp, the other Dan, just to your point as well, that when we say, look, we obviously want to try to enhance permitting, certainly not without taking into consideration all the environmental and social justice and other considerations. But I think part of what has stalled out some of these initiatives over time has been the uncertainty around the permitting and sort of what's the path, what are the next steps. So not even necessarily making it faster, it takes as long as it takes, especially with meaningful public input and so on. But just that indeed we get to some good answers and can facilitate the things that can be done quickly, and those things that might take more study can be added later. I think we've got a couple more comments or questions.
Ford?
Yes, there something going on in Oregon. The East Coast also are wave hubs, and is sort of an interface of government, university, and then private companies. And it separates the technologies that the developers don't necessarily need to prove their technologies, but that allow for side-by-side comparisons of technologies. And so there has been mention of a East Coast and a West Coast wave hub, providing electrical sockets and data gathering equipment. I was just curious whether California will likely pursue that, and especially with regard to its shelf dropping off rather quickly. I'm also concerned about marine protected areas. I can't say the name. I'm going to say Farallones, Monterey Bay, Chumash, MPA spans for quite a distance on California coast. And personally, that's why I believe technology should be actually away from this stuff, unless it's very carefully used to engender actually biogrowth on the structures, allowable biogrowth that allows for habitat restoration.
Great, thanks. And I see Dan put a note in the chat here on related to that. All right, any other comments, questions at this point? Well, I want to thank everybody for participating. This has really been great. Unless we hear an objection from any of our industry partners, we will be putting your presentations in a Dropbox that others can access so that, again, our policymakers can be fully informed. We'll also summarize, just so that, again, our busy folks, especially the staff that works for our legislative leaders, don't have to comb through 20 or 30 slide decks. we'll try to summarize the recommendations and the comments into a short report and make this just, again, the first of hopefully many interactions informing the process of SB 605, and especially if and when the bill passes, fingers crossed, it hasn't passed yet. It's gotten out of both committees, as I mentioned, with unanimous bipartisan support in both houses, but it has yet to go to the full legislature of each house. And then, of course, the governor has to sign it. So we've got a ways to go. But even if for any reason SB 605 stumbles this year, this is a great group to be working with our policymakers and our regulators on getting these technologies sustainably and equitably deployed in California. So again, unless anyone objects, please let Mebus or Chris know. Your contact information will be shared and your slides will be shared. And we will be following up with next steps as SB 605 progresses. So once again, thank you everyone for participating, especially to Chris, Mebus, Jenna for putting all of this together, Dan and Rocky for all of your support, and the whole team that keeps this machine going. And we hope to help California achieve its sustainability goals with this small step. Thanks, everyone.
Thank you.
Thanks, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Thanks.